Welcome to In 5 Minutes. We take problem on shear force and bending moment and we consider overhang beam with more than two supports. Problem statement is draw axial force, shear force and bending moment diagram for the beam as shown in the figure. So this is a given beam which consists of a hinge support at point A and two roller supports at point C and F. We have a downward point load of 20 kN at point B and an inclined point load of 50 kN at point G, and we have a clockwise moment of 10 kN magnitude at point D, and at E we have internal hinge. So in the problem we have been asked to find first the shear force diagram, second the bending moment diagram, and third the axial force diagram. So solution: first we draw support reactions at point A, C and F. Now we see, since we have an inclined load, the hinge support A will have both vertical and horizontal support reaction. So we show a vertical support reaction at point A by means of VA and we assume it to be upward, and we show horizontal support reaction at point A by means of HA, which we assume it to be rightward. Then we assume a vertical support reaction at point C denoted by VC and a vertical support reaction at point F denoted by VF. So our first step is to determine the support reactions. Now we determine the support reaction by making use of static equilibrium equation. Now we see that there are four unknown reactions and the number of static equilibrium equation that can be used is only 3, which are summation of all moments about any point is equal to 0, and summation of all vertical forces Fi is equal to 0, and summation of all horizontal forces Fx is equal to 0. So it becomes impossible to determine all the support reaction by making use of only static equilibrium equation. So we see that to determine our fourth unknown, there is additional information given, that is at point E we have an internal hinge, and we know that bending moment at internal hinge is 0. That is, we can write bending moment at point E is equal to 0. So this will provide another equation with the help of which we can find our fourth unknown. So now let's find all the support reactions. We first make use of this equation itself, which is bending moment at point E is equal to 0. Now writing the expression for bending moment at point E, we have a sign convention is clockwise moment at the left hand side of section and anti-clockwise moment at the right hand side of section is taken as positive, and anti-clockwise moment on the left hand side of section and clockwise moment on the right hand side of section is taken as negative. So now writing the bending moment equation at point E, considering the right hand side of section, we have first there is a anti-clockwise moment caused due to this vertical support reaction Vf acting at a distance of 2 meter from point E. So we have Vf into 2. Then we have a clockwise moment caused due to this UDL of 10 kN per meter acting for a span of 3 meter. So we can assume a point load of magnitude 10 into 3, which is acting at a distance of 1.5 meter from point E. So we have minus 10 into 3 into 1.5. Next we have an inclined load of 50 kN, which is inclined by an angle of 30 degree and acting at a distance of 3 meter from point E. So the vertical component of this inclined load, whose magnitude is given by 50 sine 30, will be forming a clockwise moment whose magnitude will be given by minus 50 sine 30 multiplied by 3. So this is the expression for bending moment at point E considering the right hand side of section, and this is equal to 0. Now we see that in this equation the only unknown is Vf. So after solving this, we get the value of Vf as 60 kN, which is positive. This implies that Vf is upward. So from four unknowns, we have found out your unknown support reaction Vf by using the bending moment condition. So next we find out the remaining three unknown support reactions by using the static equilibrium equation.